Hello everyone, welcome to our channel. And once upon a time, I build a circuit. We have this. Every time you touch the wire, LED turns on. And this is a transistor touch switch. We also have this. That is a MOSFET version of touch switch using IRFZ44N. And this one I'm using transistor BJT NPN type BC547C. And every time you touch the wire, LED turns on, just like this one. On. And we are interested in this human touch capacitive sensing with this circuit. And so let us see the circuit diagram of our previous circuit. We have here a transistor tester, transistor touch sensor prototype. This is a previous circuit. So we have here 9-volt supply in series, 1 kilo ohms. The LED connected to the collector, emitter grounded, and then the touch wire. So these two are the touch wire. Every time I touch the wire, LED turns on. I'm using 1 kilo ohms to limit the current flows at the LED. And I do not calculate the value of the resistor. It is just an arbitrary values. 1 kilo ohms, standard value for current limiting resistance through the LED. So in here, I'm using an old type battery terminal, or this one, battery clip. Also, I didn't finish the circuit diagram because this is a previous circuit. This is a study of the touch sensor. Unlike this one, this is using a MOSFET. But since we are interested in about the capacitive human touch switch module, I designed a new module for that circuit. And this is our new module. This is a skeleton type module of a capacitive human touch switch. So let us test. Power on. Plug in the supply. It is 9 volts. So we have now here and it is capable of standing by itself. We have now here a power on LED, the output LED, some ceramic capacitor, this one. We also have this resistor, a transistor at the bottom, and this header, and also the base is a header. So you can see here, that's the base, and it is capable of standing by itself. So let us plug in again the power supply, negative to negative, positive to positive. Now we have this power LED. Also, this is a capacitive human touch switch. So let us touch the there's a light off. When you touch the touch plate, it is on, off, on, just like the previous circuit. The only difference is this is a mosquito circuit type. This is a skeleton type. Every time you touch the wire or the touch plate, LED turns on. Also, when you slide the jumper, it is capable of having its own light. So let us see the circuit diagram of this circuit. This is the circuit diagram of our new module. This skeleton type circuit. This is our circuit diagram. We also have this, almost the same as the old circuit. The same. We have 9-volt supply, the BCC. We have this power on LED. Also, we have the output LED, and we're going to operate the transistor in saturation mode when you touch the wire or the touch plate AB. Emitter grounded, collector to base. The touch plate A connected to C, collector, and touch plate B connected to the base. And this one is the same as this one. So what makes this touch switch to turn on the LED? That is the question. Every time you touch the two terminal, LED turns on. That is what they call a capacitive human touch. Since our previous circuit, I did not compute the values of the exact values of the resistor here. I decided to compute by using an Ohm's law, or I mean the KBL, across BCC up to the transistor. We have now here KBL at BCC to transistor BCC minus the voltage drop. I mean this one. This one. BCC minus the voltage drop at RD, voltage drop at the diode, and voltage drop across the collector emitter of the transistor. Once you touch the plate, LED turns on because there is a base triggering current that flows because of the human touch, and that is we are going to discuss. By transposition, we get now this equation. Transposition, since the voltage rating of the LED is 2.0 volts, that is given in data sheet. We got now, and the collector to emitter saturation is 0.3 volts, the data sheet of the transistor. So we're going to operate to conduct the transistor in saturation mode, or it is almost a closed switch or as a switch. Transposition now, substitution, we know the value of the voltage supply 9 volts, voltage rating of the LED 2 volts, collector emitter saturation 0.3 volts. We got now the voltage drop of 6.7 volts across the resistor. To compute for the values of the resistor using Ohm's law, we got B is equal to IR. RD now, transposition, substitution. Since the current rating of LED to turn on, according to the datasheet, is 0.02 or 20 milliamps, by substitution, I, 0.02 ampere, should be volts over ampere, the unit, 335 ohms. I'm using 330 ohms, my available resistor. So we got now here at 330 ohms. That is our output LED. Now we're going to compute for the value of the power LED using KVL at BCC to D1. BCC to D1. PCC minus BR1 minus BD is equal to 0. And it is equal to 0. And BD1 is equal to 2.0. That is also given in the data sheet of the LED. By transposition, substitution, we know the values of the two. We got 7 volts. Voltage drop across R1. And then using Ohm's law, we got B is equal to IR. R1 is equal to B over I. And we know that the current rating of the LED to turn on, that is the required current, 0.02 ampere, 7 divided by 0.02 is equal to 350 ohms. I'm using 330 ohms, my available resistor. So we now already compute for the values of the resistor here to limit the current to flow into the LED, and also current limiting resistor to our output LED. This is power LED. What makes this LED to turn on? This is already turned on because this is power LED. What makes this output LED to turn on? Whenever you touch the two terminals is, they call it the capacitance, human capacitance, or because our body is capable of accumulating charges. That's why we have this human body model. We have our own capacitance value, human body capacitance value of 100 picofarad in series with 1.5 kilo ohms resistor. That is the equivalent components of a human touch. So every time you touch the terminal, this is the equivalent components or series circuit according to ESDA, Electrostatic Discharge Association. So our hands is just like this, equivalent to human capacitance of 100 picofarad in series with 1.5 kilo ohms. That is now, every time you touch the wire, the touch plate, LED turns on because our body is capable of accumulating charges and serve as a resistance to the transistor. So that's why whenever you touch the wire terminal, there is a current that flows into the base to the emitter that serve as a triggering current to the base, making the transistor to operate in saturation or almost a closed switch, and the current flows into the collector to the emitter. LED turns on. So we know that the human body model has a capacitance of 100 picofarad. That is our own body capacitance in series with 1.5 kilo ohms to produce this what they call electrostatic charges, because according to the Coulomb's formula for the charges, since our human body, our body is capable of accumulating charges. We have the formula for that. Coulombs. In coulombs, the charge is equal to capacitance times the voltage. That is the formula for charges. And we know that here, in replacement of our human hand or our own body or our own hand, we're going to replace that with the equivalent human body model components. So we're now going to connect a capacitor and a resistor to the base instead of just touching. The touching is equivalent to connecting the capacitor and resistor in series. So once you connect that, LED turns on. And we can show that by using our very own new design. This is the ceramic capacitor, 100 picofarad, and the resistor below, LED power on, output LED. We have the LED output resistor. Also we have this LED, the resistor at the of the other LED, and this resistor is for the in series with the ceramic capacitor. So this now is our new model, skeleton type circuit or module. It's so hard to construct this, although this is less expensive. We're not using PCB. The base of the module is connected to the header, and also there is a jumper here, jumper header. So this one we got here also, this 104. According to our capacitor values, 104 is equal also to 100 picofarad. 100 picofarad, that is 104. So this is now the circuit diagram of our new module, skeleton type. We have the power header, connected also the power LED in series, in the output LED, and then the transistor, and then jumper header that is located here, the jumper header. Power header is this, the base, and then transistor is located below. As you've seen here, should be below, over there. Or touch plate is in here at the side of the base. So this is now the circuit diagram with its corresponding values: 330 ohms, RD 330 ohms, transistor 2N2222, and then our human body model capacitance 104 or 100 picofarad in series with this resistor that is 1.5 kilo ohms. This is now the jumper header. We're going to switch the jumper so that every time we switch jumper at this portion from A to B, pin 1 to 2, only the current flows here and also to the base, conducting the transistor in saturation mode, turning on the LED. When you connect the header at the center, also current flows into the collector. Since this is connected to B and A, now also current flows to the capacitor, to the resistor, and to the base, to the ground. Also flows to the collector, operating the transistor in saturation mode. When you slide the jumper to terminal 3 to 4, you place the jumper in 3 to 4, AB, it is now connected only to the touch plate. That's why every time I slide the jumper, it has different output LED because of this header, the manipulation of jumper here. 3 types. First type, LED turns on. Second type, LED turns on. Third type, for the touch plate. And this is the skeleton series layout. That is the layout. You have the jumper header here at the top, as you've seen here. And then our output LED, this ceramic capacitor, resistor at the side, left side. Also resistor here. And then also the LED, the power on LED, and then a resistor below, or I mean under the LED, and then also the transistor somewhere here, somewhere there below, and also this base, which is composed of this power on header or a female header. So we have now this. We now connect the voltage supply at the base, and then powering on the skeleton type module. We have the connection here. That is the connection, and that is the layout and the schematic diagram of the touch switch using this new model skeleton type. So let us see again how this circuit works. Let us now put that again in here. So let us connect the power supply. We have now an LED turning on because our jumper setup is in the upper part, just like this one on the upper part. It means LED turns on. At the middle, also LED turns on, because if you trace the current flows, LED turns on. There is a base triggering current at the base of the transistor. And to the left, that is the function of the touch plate. So let us slide, or I mean put the header or the jumper to the left. Now it now serves as a human touch capacitive touch switch. If I touch it at the side, LED turns on. Can you see that? Oh, something wrong because of the light. Release, touch the side of the base, LED turns on. Touch the side of the base, LED turns on. Release, touch the side, LED turns on. That is the power of human touch. we are capable of accumulating charges, and at the same time we have our own body resistance that will make the base of the transistor to produce a current flows, making a base current in the transistor and lighting this LED, making this LED turn on. So if you put that here, when you're going to touch the side, LED turns on. See that? So we know that the human body has a capacitance that will make the transistor to turn on and the LED to light on, to lit up the LED by using our own hands touching the terminal of the LED. This is our first skeleton type model without using perf board or PCB. It is a PCB-less type of circuit. Less expensive but hard to do, because you're going to balance the components to make to stand on its own. You need to balance the component, and also should be symmetric design and inspired by some sort of robot, little robot. We can slide again the header, the jumper, again putting the supply. We have now the power as discussed, the current flows. We have now here an LED human body capacitive touch sensing, because that's header. I put the header at the top, making the current to flows to the transistor, and since current will not flow here because only connected here is the base, so only current flows here to the base through this spot. Also here, around here, through this spot, also almost the same as the other one, and the last one is only for the touch plate. So that is the power of human touch, making this our new skeleton type circuit. Okay, that is now the human touch switch. We are now having this circuit, human touch switch, capacitive human touch switch module. Okay, thank you for watching the video, and see you again. Stay tuned to our channel, because in the near future we're going to build much bigger skeleton type circuit, PCB less circuit. Just stay tuned to our channel. Enjoy watching, and forgive my English. Bye bye.